Hi, everyone, and thank you for joining us today for our event, MLOps in Action, How to Operationalize Your Machine Learning Workflow Using Pipeline Templates. My name is Lauren, and I'm the Content Manager for the Google Cloud community, and I'm thrilled to be here today with Customer Engineer at Google Cloud, Ivan Nardini, and Head of Machine Learning Engineering at Datatonic, Felix Schaumann. We'll be taking you through the content and answering your questions today. I know we have a full lineup and schedule to show you today, but before we do, I just want to remind you that questions are encouraged. So please feel free to add those into the YouTube chat box, and we'll be sure to get to it either in the chat or at the end of the presentation. And if we don't get to your question, you have questions still remaining, please feel free to use the Google Cloud community, and the link to that is in the YouTube description. It's there where you can engage in two-way discussion forums with your peers and Googlers, and you can find out about future events just like this one. All right, so with that, I will hand it over to the team to take us through the content today.
Awesome. Thank you so much, Lauren. So I will team tackle this one for today together with Ivan. We have lots of content prep for you, and also we'll show a demo in the later part. So without further ado, we're going to recap quickly about why does MLOps matter, and then we are going to talk about two more things. One is how you can enable MLOps in Vertex AI, and then also how you can scale the machine learning use cases in your industry, in your organization at scale by using MLOps Turbo Templates, which we're also going to demo today. And yes, towards the end, we are going to leave some time for an interactive Q&A session as well. So let's get into it. If you think about the number of ML use cases you can tackle in your organization, and you think from a perspective of a value chain, you typically start with discovering what kind of machine learning use cases do actually make sense to my industry and my company. And once discovered, you typically go through a feasibility and prioritization assessment with ultimately the aim to take the most valuable use cases and work on them, bring them out to the users and generate some predictions. And this with the ultimate aim, of course, to generate business value and get a return of investment. All of this sounds nice. However, you will only get the business value from your use cases once they're deployed to production. And throughout this process, you will actually need to cover a couple of steps, where the first one is building your model, of course. But building your model is not just about doing your typical exploratory data analysis, your model training, and also evaluating your model to find actually the best performing model which you want to put forward to your internal or external customers. You actually need to think about repeatability and automation. And this is where really the build of machine learning pipelines kicks in, because this is not a one-off exercise. You actually want to make sure that you can train your models and use them for prediction over and over again. And this is where automation is really so important. And this is really the backbone before you then use those models and serve them, bring them out to the customers. All of these three steps sound linear, very trivial, but in reality, you will realize it's not that easy. And just to highlight a couple of common pain points when you tackle not just your first ML use case, but actually a variety of ML use cases, is that first, a lack of standards is really a big hurdle and which stops you from scaling your machine learning use cases at scale in your organization. And this is because of multiple reasons. One to point out is a lack of clear ownership and consistency, and over resulting in missed opportunities. You will also see, secondly, a slow time to production. And just looking at the number of use cases which ultimately make it into production, there's still a small fraction of models which actually finally get into production. And this is not just due to the lack of standards, but a variety of reasons. And thirdly, I want to point out, even if your model makes it into production, you will notice that the model performance isn't something static. It will actually change over time, and worst case, it will decay over time. And this really starts once you have put your model into production, into a live environment where it interacts with the ever-changing data in our world. And then lastly, you might even realize that your model is behaving as expected in production. However, there are high costs and manual efforts involved in actually maintaining those models. So to actually get around all these obstacles to finally enable scale in your organization for your machine learning use cases, I would like to talk today with Ivan about MLOps. And MLOps is really the set of best practices and guidelines and technology and tools which are designed to build, manage, and optimize your machine learning models throughout their whole life cycle. So let this soak in just for a moment. It's a set of best practices and guidelines, which means any kind of tools you use in your organization should actually adhere to those guidelines. But you also need to be very careful with the tech you're choosing when you actually design your machine learning use cases. And this is really what we're covering today. So as a next step, let me shortly look at the value chain again and see how those MLOps best practices can actually help with bringing your machine learning use case into production. And one of the first things you need to think about is strong machine learning foundations and data science experiments. You need to actually create an environment where your data scientists, your data science team, and generally your ML practitioners can start in a standardized environment, but also can start with their data science experiments as soon as possible. And this is really the first step before them thinking about building a machine learning pipelines. And with contrast to the slide we've seen before, this is really an iterative process. This is not sequential. So you build your machine learning pipelines with the aim to serve the models at the end of the day. But then after serving the models, you need to think about monitoring the model performance continuously. And whenever you see that your model performance is actually decaying, there needs to be a process, best case automatically, which can optimize your machine learning models. And this comes back essentially to the build of machine learning pipelines, because an automated retraining of your models requires machine learning pipelines which are standardized, which can retrain your models, and also automation to bring those models and the new updates of the models to your production environment. And yes, typically we see in practice that all of these things can be wrapped together in a so-called MLOps platform, which is really a set of multiple MLOps components, which you can put together in a platform to ultimately serve your data science teams and also your ML practitioners in the organization. So this is really exciting. And since we can't cover everything today, let's focus just on a few bits where overall you have to keep in mind that key benefits of MLOps are, of course, an accelerated time to production. You want to standardize and scale your data science machine learning use cases. You don't want just to go through the pain of putting one machine learning use case into production environment. You want to do that for 10, maybe hundreds of use cases and so on. So that's why MLOps is really relevant. And then overall, of course, a couple of key benefits which we want to focus on is reducing the manual effort and also the cost to maintaining those machine learning models. And ultimately with the aim to ensure the model performance over time is actually as high as necessary so that you can get actually return of your investment and also get the business value which you were hoping for. So with those benefits in mind, for today's session, we really want to focus on the machine learning pipelines because it's one of the important backbones of MLOps. So for machine learning pipelines, let's maybe think quickly about how does a pipeline look like. It's actually quite straightforward. It's a sequence of steps which you can put together in a pipeline. And as you can see here on the right-hand side, those could be steps such as ingesting your training data, pre-processing and cleaning your data before you then run more steps based on this data. And this would be, for example, checking the data for drift or skew, for example, and then ultimately also using it for training and predicting. So all of this can be a machine learning pipeline, but overall, of course, depends also on your specific machine learning use case. At scale, you actually need to run and maintain those pipelines. So that means this is not a single pipeline you will need to take care of. There will be actually a multiple set of machine learning pipelines, depending on your use case, but also maybe depending on the machine learning framework you're using, whether this is scikit-learn, XGBoost, TensorFlow, PyTorch, and so on. And then you will also need to take care about the fact that you need to build, test, and publish those machine learning pipelines into different environments, because those machine learning pipelines are typically tested in a sandbox environment before then bringing into a staging and finally into a production environment. Then you will also need to think about how you can trigger those pipelines. Think about a simple example where you want to retrain your model on a weekly basis. Well, this is where you need to have a scheduler in mind, which can trigger your training pipeline on a weekly basis. But there are also more advanced machine learning use cases where you maybe want to do that on different kinds of events. And then lastly, machine learning pipelines need, of course, an orchestration service. They need cloud resources and also infrastructure. As such, you need to keep infrastructure as code also in mind when you want to deploy your pipelines. Here's also just another quick peek into the fact that machine learning pipelines in production are one essential piece, of course, in your MLOps platform, but there's so many interacting pieces. And without going too much into detail on the picture here on the right-hand side, I just want to point out that there will be several teams interacting with your machine learning use cases, whether this is an ML engineering team or your data science team. But ultimately, those teams need to ensure that they can run the experiments they would like to run. Then also take your machine learning pipelines, test them, but then also have an process which ties that together with your visual control system, whether this is GitLab, GitHub, or so on, so that you can actually keep one source of truth for machine learning pipelines before you build, test, and deploy them into your various environments. And here on the right-hand side, you can see that we have another test and production environment. So this is really exciting. And as a next step, I would like Ivan actually to introduce that with the Vertex AI platform on Google Cloud, you can actually do all of this. You can build and scale your machine learning pipelines faster. And you can also make use of the fact that Vertex AI is a really integrated OpenAI platform with an ever-growing number of features. And yeah, for that, I'll pass it over to you.
Thank you, Felix. So as Felix mentioned, with Vertex AI, you really can scale machine learning pipelines and use them in your use case. So let's see how the platform can help doing this. So when we talk about Vertex AI, for who doesn't know what Vertex AI is, Vertex AI is an open, managed, and scalable platform that allows you to build and operationalize both predictive AI and generative AI use case. In particular, the platform has been designed to speed up the process of experimentation and to operationalize AI models. And because of that, we, as you can see in these slides, MLOps has been part of the core services of the platform itself. And one of the key services that we use in order to implement MLOps on Vertex AI platform is Vertex AI Pipeline. So with Vertex AI Pipeline, what you can do, you can run machine learning pipelines that has been built using Kubeflow Pipeline SDK or TensorFlow Extended, which are the most common frameworks to run machine learning pipelines at scale without taking care of the infrastructure that is needed for running machine learning pipeline using those two frameworks. And also the platform and the services actually the Vertex AI pipelines comes with some per-build components, which are represented by the Google Cloud pipeline components, which are components that we provide as a Google Cloud that are designed to be production ready and allows you to interact with other services of the Google Cloud platform. For example, if you want to do a step of preprocessing and you have your data on BigQuery, we provide some pipeline components that allows you to submit your preprocessing SQL code on BigQuery directly from a pipeline. And this is just an example. There are several components, one for each step of the machine learning pipeline that we are going to build. Of course, you can also build your custom components. And as I said, the services support TFX and TFP, so you can define your logic and the kind of steps that you want to integrate in your pipelines based on your needs. The other important thing is that Vertex AI Pipeline is not just a service that allows you to run machine learning pipelines, but is also integrated with other key services that characterize the process of MLOps. So that are part of something that it's represented by a machine learning platform. So for example, with Vertex AI Pipelines, you can create a components that reads features, aggregated feature from a feature store, which is a repository that allows you to share and use machine learning features across different use case. Also, the services allows you to track all the input and output that will be generated by each step of the pipeline in such a way that you get a lineage of the pipeline, and you are always able to reconstruct what were the input and what were the output of a single component in all the steps of the pipeline itself. Also, once you train your model using machine learning pipeline or Vertex AI pipelines, you have component that allows you, for example, to register different version of the model inside the Vertex AI model registry, which is a repository that allow you to version models that you train on Vertex AI. And also, you can use Vertex AI pipelines to, let's say, run model monitoring jobs. So a model evaluation job. So in a way that you can always tracking the performance of the model and evaluate how the training goes every time that you execute a new machine learning pipeline. So this is just to give you an idea of how Vertex AI pipelines can really help you to, let's say, run your machine learning pipelines, but also thanks to the integration that the services has with other MLOps services, it allows you to consolidate a machine learning platform overall. The thing is that machine learning pipelines are just a part of a machine learning platform. And imagine that you are a data scientist, and you just have your code that you use to train, or you have your code that you use to generate the prediction using the model that you just trained. How you can turn this code in a repeatable pipeline, and how this pipeline, once you get it, can go to production, possible in an automated way. So that's the kind of challenges that MLOps template can solve. So I will hand over to Felix, which will talk about how to build an MLOps template.
Awesome. Thank you so much, Ivan. And all of this, of course, with the aim to speeding up the adoption. Let me introduce you to the so-called turbo template. Think about this, the turbo which accelerates your speed going to production, but we can also call them MLOps templates. The turbo templates are really your go-to reference implementation when it comes to Vertex AI pipelines for your ML use cases. And that's because of a couple of reasons. One is it already provides you most of the core features you need when you want to productionalize a use case. This is, for example, your continuous integration and deployment pipelines, so overall your automation, but also it gives you all the infrastructure as code which you need to actually automate the deployment across not just a single sandbox environment, but actually up to test production and so on. Furthermore, it actually includes also those ML pipelines as backbones, right? So they're the components. You will find machine learning pipelines which will really help you to get started quickly. And all of them are actually tested. Because testing is actually one important thing we want to ensure before you actually deploy your machine learning pipelines. And lastly, there are also quite a few helper scripts which help you accelerating the development. So these templates are really meant for any kind of AI practitioner to get started as quickly as possible with an MLOps template. And for that, you will most likely need Python skills, and the rest you will just explore. So let's dive into it later on in the demo. But if I were to open up the turbo templates and tell you what's inside, well, at first, and quite obviously, a training pipeline, which will go through quite a few operations when it comes to your data, validation, model training, evaluation, deployment. So all of the good stuff you need in training pipeline. Then secondly, there's also a prediction pipeline, which you can actually use to generate predictions for your customers. And this will largely actually use the batch prediction service in Vertex AI to ensure a scale of your data. And then lastly, as I said before, we have CI/CD and infrastructure as code artifacts in there, which help you to get started fast by using Cloud Build for automation and Terraform for actually defining the infrastructure which you need in your cloud environment. So let's go through all of these three things step by step. If you open up the Turbo template, one of the first things you might want to look at is the flexible training pipeline. And this will go through a few steps. The pipeline itself is using Vertex AI Pipelines, obviously, but also the way how you define your pipeline is actually based on Kubeflow. And we're going to actually cover a couple of Kubeflow specifics later on. But with this definition, you can really put the most logical steps in your training pipeline in the right sequential order to actually create an end-to-end training pipeline. So as a first step, you typically need in a machine learning use case, your data ingestion, pre-processing, and your train validation and test split. And for this, you will actually see later on, we're going to use BigQuery. So you can actually query your data from your source data. You can ingest it in your machine learning project, and then you can start cleaning up the data and maybe even developing a couple of ML features, which you later on need for your model training. So after those essential data operations, we actually have the most critical step in the machine learning pipeline, which is the model training step. And within, you will see a reference implementation of training a simple XGBoost example by using XGBoost and scikit-learn. But the nice thing about this template is that with any kind of machine learning use case, as long as you can put it in a Docker container and maybe use Python for it, you can put it into your model training pipeline. You are not limited to just using XGBoost. You can bring any library to the template. So after training your model, you will most likely have a model artifact which you seek to actually productionalize. But before you do so, we of course need to evaluate the model. And what the MLOps template provides you is the typical champion challenger approach. And what that refers to is that if you think about retraining multiple versions of your model and you put all of them in a version model registry in Vertex AI, you would typically need to see whether the new challenger model, that's the one you just trained, is actually better than your existing best model. And that's what we call the champion. So the challenger will actually only be deployed if compared to the previous champion, if it exists, is better. And this usually by using a primary evaluation metric. Think about a regression use case. This could be, for example, your root mean square error. Only if this one is lower, then we would go about uploading the most recent trained model, your challenger, uploading also its evaluation results for future, for lineage, and then actually make it ready for model deployment. And this is the training pipeline in a wrap. So really straightforward. Let me now advance to the scalable prediction pipeline. You will notice a few similar steps. For example, you can repeat your typical data operation steps with, this is, for example, some BigQuery SQL code where you get your newly ingested data, pre-process it similarly to your training pipeline, so that you now have some pre-processed data ready for predictions. And what we're going to use here is batch predictions. And within Vertex AI, there is already a service which you can use for that. This is called the batch prediction service. And something I really like about the Vertex AI batch prediction service is that you can actually take directly data from BigQuery natively, your input data. You run all the batch predictions using your previously trained model in your training pipeline, and you even output the data directly into BigQuery again. So this is really nice if you are using tabular data, which is a pretty common input and output for machine learning use cases in your prediction pipeline. And then if you wanted to, you can do some post-processing, really bring those predictions up to shape before you then actually serve them out to your customers. But this is not the last step. The last step is actually about monitoring, and it's really crucial because once you run your batch prediction job and you have the most recent predictions using your best champion model, we actually need to make sure that your data, the ones which we have now used for your batch prediction job, has actually not skewed away from your training data. And this is really by just being cognizant of the fact that the data in our world is just changing ever and ever again. So if actually the skew thresholds are exceeded, you will also get alerted, and then your data scientists, machine learning engineers, or generally your AI practitioner team can act on those alerts to ensure that your model is actually still representative of the real world. So that's really a wrap when it comes to the prediction pipeline. And both of them, I would say, are underpinned by the automation templates within Codebase. And these are about building, testing, and deploying your ML use cases continuously. And this typically includes pull request checks, releases, and also your infrastructure apply or Terraform apply. So in order to start with the pull request checks, this is really something super helpful whenever you want to make changes, code changes to your machine learning use case. Because a pull request check really makes sure that all the recent code changes are performing as expected. And thus, we actually have prepared a pull request check pipeline for you, which you can run within Cloud Build. This is the automation service in Google Cloud, to install all the required dependencies, run some pre-commit checks. This could be as simple as, have you used the right formatting? Before then running your unit tests and also you're compiling your machine learning pipelines. All of these steps help you to not introduce any kind of mistakes, errors, or bugs into your machine learning pipelines before you deploy them. So this will run on any code change which you upload to your code repository. And then the release will actually make sure that you can take your machine learning pipelines from one environment to the next one. So we will again install the dependencies, we compile the machine learning pipelines, and then most importantly, those machine learning pipelines, you can think about them as a text file at this point. You can actually upload them in a versioned manner from one environment to the next one. And this could be, for example, from your sandbox environment to your test environment. And then after uploading them to the new environment, you would actually run them end to end to ensure that they are actually running as expected. And yes, lastly, we also have a Terraform apply ready for you. And this simply ensures that all the cloud resources you want to deploy in order to orchestrate your machine learning pipelines, to trigger them, to schedule them, are actually available in your Google Cloud project. And this is done by using the open source solution Terraform. And yeah, we have a couple of templates available for you where you can in total provision 3 environments, but you could also change the number of environments if you wanted to. And all of these 3 things chunked together mean that you can now actually bring your prediction and also your training pipelines by using automation into a production environment, by also ensuring that they're built and tested continuously. And that's really what the Turbo templates are about. One more thing I wanted to point out, though, is that since Vertex AI Pipelines are based on the open source package Kubeflow, and this is the package which we are using for orchestrating all our steps in our machine learning pipeline and also defining them actually in code, Kubeflow has actually recently evolved. We don't have any more Kubeflow version 1 around. We are now in the world of version 2 Kubeflow. So I just wanted to go through a couple of highlights. If you were to implement your first machine learning pipeline after today's webinar, please ensure that you understand those changes when going from SDK version 1 point something to the most recent Kubeflow SDK 2.0. And yeah, by going actually through a full definition of a machine learning pipeline, and this is really just an exemplary code, I would like to highlight that one of the first things you need to do is you need to import Kubeflow. So you do a from KFP import and then all the necessary objects which you need from KFP. And you will actually see that as a change from the previous SDK version, we now no more need to define kfb.v2. Actually, we can now directly import from KFP because this is now the standard go-to import object which you can use in your pipelines. So that's really nice. And as a next thing you typically do in your machine learning pipeline is you need to define a component. Here I have created a really stupid training component which only prints out the number of epochs and the learning rate itself. Typically, you would have, of course, more logic to it. But in the previous SDK version, in version 1, you could actually save this single component into a file by using the annotation which you see on the top left side, where you put it into my component.yaml. This is something you don't do anymore, actually, in the second version of Kubeflow. You would use that typically through the compiler, which you will see in a sec. Then one change, and this is the one I'm actually really excited about, is container components. With Kubeflow version 2, you don't necessarily have to define your machine learning pipeline steps using Python. You can also use an existing Docker container. And here, for example, I've created a container which uses the Google Cloud SDK container from the Docker Hub registry. And in there, I will simply run a BigQuery command and execute essentially just a SQL command. And this is really useful if you already have a container which bundles most of the business logic. And you will see later on in the template that we also use the container component where it suits the best. So after defining a couple of steps, you would typically then go about putting all of them into a logical sequence in your pipeline. So you have to define your pipeline. And 2 changes just to point out going to the newest KFP version. One is whenever you call your component, be sure that you use keyword arguments. So you can't just call your training component by saying 100 and 0.1. You always have to define what kind of argument will receive that value. So in our case, epochs is 100 and learning rate is 0.1 and not the other way around. And yes, finally, when you want to compile your pipeline, and that is essentially the file which you will promote from one environment to another, you can't use the JSON definition anymore. Nowadays, you need to stick to the preferred format, which is YAML. So whenever you save a pipeline or even a component using the KFP compiler, be sure that you save it in a YAML format. So until now, we have imported all the necessary things from KFP. We have defined our components. We have a pipeline which is compiled. So the only thing which is now missing is running it in Vertex AI. Previously, there was an AI platform client in the KFP package. With the newest version, you actually don't need to use this one anymore. The preferred way of triggering and starting your machine learning pipeline Vertex AI is by using the Google Cloud.ai platform package. And by using this package, you simply have to point to the cloud project you want to use and also the location. And then you can use the pipeline job object to then actually trigger a pipeline. And for this, you will need to give it, of course, a display name. So what's the name of the pipeline? In our case, would be a really simple training pipeline. And then you have to point it to the compiled path where you have your YAML pipeline definition, which you just compiled. And lastly, you also need the pipeline route, which is typically a Google Cloud storage bucket. And then you submit it, and this will run your pipeline. So that's really a wrap. And all in all, I just want to say that the most recent Turbo template is luckily compliant with all those Kubeflow 2.0 changes, whether this is your training or your prediction pipeline. And while providing quite a few code enhancements, you will see that the training and prediction pipeline are just much faster than what we have done in the previous release. And then on the automation side of things, on the right-hand side, we have actually rewritten the whole Terraform and CI/CD code ground up. And now it's even simpler than before to deploy all your environments where you can then productionalize machine learning pipelines. And yes, that's really everything I wanted to talk about before jumping into today's demo. Thanks so much for listening so far.
Okay, so as a next step of this session, let's see how Turbo templates work. So let's see them in action. So let me share my screen. Okay. So when you start, I mean, imagine that you want to use the Turbo template for a new machine learning project. The first thing you may want to know is that how I can get, for example, a notebook environment. Let's say so to use the Turbo template. So as I mentioned at the beginning, for who doesn't know Vertex AI, this is how it looks like on Google Cloud Platform. As I mentioned, Vertex AI has several services. You can see on the left that, as I said, they cover both use cases related to predictive AI and generative AI. For today, we're gonna use all the services related to our predictive AI use cases, and one of them is Workbench, which gives you a managed. It's a services that gives you a managed Jupyter lab environments that you can use for example, for prototyping. So once you create a Jupyter, once you create a Workbench instance, what you get is a Jupyter Lab environment. And if we jump in the environment, this is how it would look like. So it's something that probably you are familiar with. It's a notebook environment, and so from that, from there, you can start like experimenting with your code. In particular, if you want to use turbo templates, once you git clone the turbo templates from the GitHub repo that Felix was mentioning before, this is more or less the structure that you get. So you have all the modules that allows you to create the infrastructure to run machine learning pipelines, but also you get some pre-built components, and everything is well documented. So let's see something that it might look familiar to you. So if we go in under the model folder, we can see that the folder is structured as a Python package, and it has several subfolders. One of them is related to the training. And if I click on the training module, here you can see that this is the module that probably you will use to train your model. So the modules, what it does, simply read the data that are stored in a bucket in this case. It does some machine learning transformation in order to calculate feature, and then it trains XGBoost regression, because in this case, the use case, we want to predict the tips for taxi for the taxi driver. So this is the code that you probably use. Now the question is how you can turn this code into a machine learning pipeline, in particular in a machine learning pipeline component, which will be a step of a machine learning pipeline. So if we jump in the pipelines folder, what you have is a source code. And in the source code, you have an example of what could be a possible machine learning pipeline to run the training of the model. If you see the module inside the training py module, you can see that associated to the training code that I was mentioning, that I showed you before, it has been created for you a container component. That basically what it does, it allows you to turn the module of training, so the code that you define in order to train the model, into a component of a machine learning pipeline. And so what, as you can see from the code, what it does, it defines some kind of representation of the code. It defines the inputs that the code is expecting and the outputs, so the artifacts that the codes that your code for training the model needs in order to train the model, and the kind of outputs that the code generates. So in this case, for example, as you can expect it, the training code will generate, for example, a model and some metrics associated to the training process itself. And then because it's a container component, what it allows you to do is to define the arguments and the training runtime that will be used in order to run that particular code. So in this case, the training code. So this is a way to turn like a training code into a component of a machine learning pipeline. And if you do this for all the other steps of your machine learning process, you will get a pipeline representation of the process. Now, before to show you the pipeline itself, what I want to highlight is that this is just a way to build pipeline components. And for example, as I mentioned in the presentation, you can also think to reuse some pre-built pipeline component. And in the Turbo template, actually, you have some pre-built component, for example, to interact with BigQuery, just to give you an idea. So once you get, as I said, once you get one component for each step of your machine learning process, what you can do is that you can create a pipeline representation, which actually creates this machine learning workflow, and it allows you to cover the entire end-to-end in order to train, and in this case, versioning the model inside the model registry. So this is how a machine learning pipeline will look like. So just to recap, you start from your machine learning code, and then you create components associated to the code. In this case, as I showed you before, we created a container component which use Docker image in order to run your training code. And then you do this for each step of the ML workflow that you want to define, and you initialize what is called a pipeline object that it is used to represent the pipeline itself. Once you get the pipeline, you need then you can submit this pipeline as a pipeline job on Vertex AI Pipelines, as Felix was mentioning. But this is how, this is the process that the process that I just described is something that you can manage manually if, for example, you have one use case, two use case. But because at scale you will have several use cases, what you need is more like a framework that allows you to automate the process of creating each component of the machine learning pipeline, creating, for example, the container associated to each component, and testing the machine learning pipeline before to run the pipeline on Vertex AI pipeline services. So that's exactly what the reason why you want to have a template like the Turbo template that we are discussing today. Once you will clone the Turbo template, you will find in the documentation folder the notebooks that I'm going to show you now. So I'm just pointing out to this because you may want to reproduce the notebook by yourself as well. So the notebook is quite straightforward. So the first thing that you have to do is to install some dependency related to poetry. In this case, we already installed it, so we don't need to install it again. And then you initialize the Vertex AI project ID that you are going to use in order to run the machine learning pipelines, both for training and prediction. And then what you do, you go inside the Turbo templates repository or folder, and you use make install in order to install all the dependencies that are needed in order to run the Turbo template and the pipelines and pipelines associated to it. Once you have done this, what you need to do in order to run your first machine learning pipeline for training a model is just using a simple command related to the makefile. So this simple command, what will do three main things. First of all, it will compile the machine learning pipeline. Then it will build both the training image in order to execute the training code that I was showing you before, and it will also build the serving pipeline that we are going to use in order to deploy the machine learning pipeline to generate the prediction later. Why is that? Because the step of versioning the model inside the Vertex AI model registry, which is the last step of our training machine learning pipelines, require the container to serve the model. So that's why we are building the serving container to generate the prediction in advance. So this operation, it will take some minutes, but let me show you meantime, what is happening behind the scene. So as I said, first we are going to build both the training image and the prediction image. So using managed services, which is cloud build on Google Cloud. So if we jump in the cloud build UI, as you can see, cloud build pipeline is running. And if we click on the cloud build pipeline, we can see that what is happening behind the scene is the pipeline is building, actually builds the container that we are going to use for training and serving the model. So this is how it looks like. After it finished. So install all the dependencies and everything is needed in order to create the correct runtime for our training code and serving code.
This is really cool, Ivan. I'm wondering, when I define my model code, we looked into the training code and we built the Docker container out of it. Where's the Docker file, which actually defines how this training image is built before we then use it in the pipeline?
Oh, that's a really good question. And if we jump in the notebook, let me show you. In the model, we have the Docker file that allows me which is the Docker file that is used in order to define the training and the serving images, as you can see here. So again, with the Turbo template, I already have this Docker file that allows me to create the environments that I need in order to run training and serve my model. Okay, so now that we got both images, as I said, we have the training image, we have the serving image. Then we are able to run the machine learning pipeline. So as you can see here in this step, new pipeline job has been created, and it used the compiled pipeline that it was in the first step, and the images that has been built in order to run a full machine learning pipeline that will train our model and register the model inside the model registry. So if we want to see what is happening, let me jump in the Vertex AI pipeline view. So here is the Vertex AI pipelines view, and as you can see, I have many runs, and the last one is the one it just starts. So if we look at the run here, let me do this, and let me see if I can zoom out a little bit so I can close the view. No. Okay. Yeah, let me do this. I can zoom out a little bit so you can see better. So this is how our pipeline looks like. And so as I mentioned, the first step is to ingest and preprocess the data. And then I will use this data in order to define the data set that I want to use for training my model. And once the model training finished, the model will be registered in the model registry. So these are this is how my pipeline looks like. For each pipeline step, as I mentioned before, you have several input artifact and output artifact. So for example, after I define my training sample, I get the data artifact, which represent the data set that I'm going to use in the training model step. And then the training model step generates different artifacts as well, including the model and the metrics that I mentioned. So this is how the pipeline looks like. Now, this process will take some time. So let me show you an example of a pipeline that already run. Okay. So in this case, because I have already run the pipeline, all the, let me do this exactly, and then let me zoom out again. All the components are cached, but again, the idea here is just to show you how the flow, how the pipeline will look like at the end of the process. So with the model that has been trained and register in a Vertex AI model registry. And if we want to, let me do this. If we want to see the new version of the model that has been registered, what I can do, I can jump in the Vertex AI model registry. And this is how the model registry might look like in your case. So here is the model that I register in the model registry. And actually, I register several versions because, for example, I retrained my model. So in this case, because me and Felix, we tested this demo several times during this week, we got 70 versions of the model. And if I click on the latest version, which is the default one, what I get is this full view of the model with several windows windows. Let me say so. So the first one is related to the model evaluation part. So after you train the model using the machine learning pipeline that I was showing you before, I get some metrics related to the forecasting task or the prediction task that I'm trying to implement. And then also I get several information about the version of the model. So the model ID, the container image that has been used, some information about the container that will be used to serve the model, and so on. So this is just the two main things. Also, for model registry, what you can do, you can directly deploy the model to an endpoint, and you can also start a batch prediction job, which in our case, what we are going to do, we are going to orchestrate with a prediction pipelines. Okay, so let's see if the training pipeline finished. Stop. So I think the training pipeline is still running. Let me check, because it will take some time. In case we will proceed, and I will show you how to start also a prediction pipeline. So let me see. Okay, so the pipeline, it seems that almost, yeah. So as you can see here, the training ran successfully, and now we are registering the model, a new version of the model inside the model registry. So after it finished, we can take the latest version of this model and use in a machine learning pipeline that generates the prediction. So yeah, let's wait.
Really nice, Ivan. We actually got a few questions just on this pipeline. I can maybe just answer them while we look at this. One question, for example, was about how can I make sure that all the different versions I trained of a model actually go into the registry? And the simple answer here is, whenever you run this machine learning pipeline, even if your new model is not better as the one before, it will still go into the model registry. So if you run different experiments, you run the machine learning pipeline 10 times with different hyperparameters, for example, you will see all of them coming up in the model registry. And then you can actually check again which one is the best one. Only the best one will get the default tag. So that's possible. Another question which just popped up was about pre-processing. And I think in this pipeline right now, you have two choices where you want to put pre-processing. If you scroll up just a tiny bit, Ivan, to the beginning of the pipeline.
Yeah, let me do that.
Thank you so
Let
much.
me do that.
Nice, nice. You can, for example, pre-process your data by using SQL. Because if your data is already in BigQuery, you can use any kind of SQL syntax to pre-process it and to clean it, for example. But this is not the only way. You can also put any kind of pre-processing logic, let's say, for example, with your preferred Python library, whether this is NumPy, Pandas, scikit-learn, and so on. You can also do it directly in the training step. So any kind of Python code you can bring also into this container. So that's possible. I really hope this answered your question. Thanks for raising it.
Yeah, and I mean, the model is still okay. We got it. So as you can see, the pipeline ran successfully. We got a new version of the model, and actually you can get more details about the artifact that has been registered, looking at the lineage associated to these pipelines. But now let's jump back to the notebook, because I think the machine learning pipelines to generate prediction is also very interesting to have a look at. So this is more or less how the pipeline will look like in the console. And again, because we are using the Turbo template, and what you have to do, you have just to run a make command. But in this case, we are going to set the prediction rather than training arguments. And as you see, the steps are similar to the previous one, except that now we already built the container for serving. So the only thing that happened is that a pipeline for prediction has been compiled. And actually, let me jump into those pipelines, because I didn't show you before. So if we go in the source folder pipelines, here are the two pipelines that has been compiled. And in particular, if we look at the prediction one, this is how it look like. So this is the specification of the pipeline that now we are using to generate the prediction. And if we now jump also in the Vertex AI pipeline view, so let me do that. I can show you that a new pipeline has been start. I mean, is running. A new pipeline is running. And if we click on the pipeline, as I mentioned before, this is how the pipeline will look like. Now, compared to the training pipeline, this pipeline will take a little bit more time, because we are running a batch prediction job. So we are passing the pipeline a large batch of data, and we are applying the model that I just trained to those data in order to generate the prediction. One interesting thing is that with the Turbo template, there is this custom component that allow the pipeline to pick the best performing model that I register for a particular model. So the best performing version of the model that I register in the Vertex AI registry. It picked the best one, and then it used in order to run the batch prediction job. So as I said, this pipeline will take some time. So what I can do, I can show you the results of the pipeline, which is quite similar to the one that I show you for prediction, except that now we are running a pipeline to generate, similar to the one that I show you for training, except that now we are running a pipeline that generates the prediction. So this is how it looked like. And again, notice how also in this case, we track all the artifacts associated to the pipeline. So the model and the table that will be generated by the preprocessing step before to feed the batch prediction job. So in this way, you can always say, okay, in order to generate a particular batch of prediction, I use this particular model that has been applied on this particular table. If you want to, one thing that I want to show you is that when you run this batch prediction job, actually we are using one of the Vertex AI batch prediction, one of the Vertex AI platform services, which is Vertex AI batch prediction. In fact, this is the job that we are running using the pipeline that I just showed you, and these are the previous one. Now, with these services, you can see that a lot of information are collected, right, for the batch prediction job. So you have the model that has been used, if the objective, if it is custom or not, but also the interesting part is related to monitoring. That's because the services and Vertex AI platform support a monitoring services for the batch prediction. In fact, if I click on the batch prediction, here I can see all the information about the job itself. So which data has been used, when it ran, how long it takes, and more. The version of model that has been used. But then if I go on in the monitor feature, I can see that payment. These are the features that I define and that I want to monitor, and I can see that there is an alert related to the payment type. And if I click on the payment type, I can see that okay, during training, the payment type has this distribution. While I use the model to apply the prediction, the payment type feature change the distribution, although the change is not visible, but it has been tracked by the alert itself. So this is just to give you an idea how, thanks to Vertex AI pipelines, you can leverage other services of the Vertex AI platform in order to cover really the end-to-end of a machine learning project, starting from training, as I show you, going to prediction, and also monitoring the model. Okay, I don't know, Felix, but I think I showed everything we have for our audience.
Yeah, I would say so. Thanks so much. Really liked it.
Okay, so I think it's time to jump to the conclusion. So we start this session talking about why MLOps. And Felix, I think, well explained that MLOps at the end allows you to scale a machine learning project, but more important, it allows you to realize the value of machine learning in a business context. Then, we discussed how Vertex AI platform can really help you to accelerate the process of adopting MLOps in an enterprise context. And then with the Turbo template, we see how it's not just a matter of machine learning pipelines. I mean, MLOps is not just related to machine learning pipelines, but it's a set of technologies and techniques and best practices that you need to put together in a way that you can really then scale machine learning in an enterprise context. So I hope you enjoyed the session, and I think I leave to you, Lauren, for the rest.
Yes, absolutely. Well, thank you so much for this information and the demo. I certainly learned a lot, and thank you all for joining us. I know we're a little bit over time, but we still want to make sure we're covering all of your questions. So we're going to dive right in. But before we do, I'm just going to share a few additional resources for you. And I've dropped it into the chat. But if you have any feedback for today's session or topics or suggestions that we should cover for future sessions, we'd love to hear from you. So it should just take about 30 seconds to complete that form. And then if you have any additional questions that we weren't able to cover today, the community is the place for you to be able to ask those questions and find your answers. And then lastly, just teasing a few additional events that we have coming up at the end of the month and in the beginning of December related to AI. All right, so let's dive in. I know we still had a few remaining in the chat, so I'm going to cover those first. So our first question that I'll bring up is it possible to replace tools used in these templates, for example, using Jenkins instead of Cloud Build? And if yes, how do these replacements affect the entire process?
Yeah, absolutely. I would love to have an architecture slide right now about a platform. I don't, but what I can tell you is that there are quite a few components which are covered in those templates. One of those components is the automation, and yes, you can swap it out. So what you would typically need to do is you check all the existing cloud build steps, and you can replicate them with another CI/CD tool. We have done that previously. There's no issue with taking this, for example, into GitHub Actions. That's absolutely possible because each of those components has an interface. And in our case, the CI pipelines are triggered whenever you make a code change and when you make a release. So if you want to use Jenkins, well, recreate similar pipelines using Jenkins upon a pull request and also upon a release. And yeah, that's the way to go.
Fantastic. Thank you for that. Okay, our next question is, how can you identify what type instance type we have to choose for the model run?
I can cover this one, but please add even if I'm missing anything. With Kubeflow, there's a built-in functionality where you can decide on the memory size, but also on the compute used for every single step in your pipeline, whether it's a container, whether it's a Python component whatsoever. I would like to point out that for batch prediction jobs, it's a bit different though, because batch prediction jobs is a managed service in Vertex AI. So when you run this job, you can actually set what kind of instance you want to use. And just look up all the available compute instances, whether it's an N1, N2, and so on, or the C1s and so on. And you can also decide whether you would like to add accelerators. In our simple prediction pipeline, XGBoost, we didn't need a GPU accelerator, but when you run your batch prediction job and you realize it's very slow, maybe you forgot to add a GPU acceleration. But both of them are inputs to the batch prediction component, which will run that batch prediction job. Yeah, that's really it.
Great. And I think that kind of brings us into the next question around batch predictions. Would there be a difference in the workflow? And I think you just touched on a little bit of that, or the template, whether you're doing a batch or streaming, I would assume, model or prediction.
Yeah, good one. One thing we noticed when we created those initial MLOps templates is you can't cover it all. There's not a single master template which exists for any kind of use case. So the current Turbo template only focuses on batch use cases where you have a scheduled training pipeline and a scheduled prediction pipeline. I would though encourage you to maybe check out a couple of components which you might find useful for also implementing it then for a streaming use case. And this could be, for example, the automation pipelines. But overall, I would say streaming right now is not part of the current template code. But hey, the sky's the limit. Maybe in future we could add another template just for streaming. Why not?
Yeah, just go on the repo and open a feature request.
Might be a big one though.
Perfect. All right. Well, we just have a few more, so thank you so much. Does this workflow template change for real-time predictions? And then a similar question, is there a template for that?
Yeah, good one. So for sometimes I rather say near real-time because it can be confused with streaming. For near real-time use case, I would say use the training pipeline and the automation as is. But as Ivan has shown in the Vertex UI, there is actually a simple way of deploying your model also in the endpoint. Maybe you want to touch upon this, Ivan, but I think that's straightforward, isn't it?
Yeah, no, exactly. And maybe I would say that you need to change a little bit the pipeline to, like, I mean, in the demo we show that we have a pipeline to run the batch prediction, right? So what you can do is that you can have like a CD, so continuous deployment pipeline, that before to deploy the model in an endpoint, maybe run some unit test, integration test, and then deploy the model in an endpoint, so you can receive online requests and generate online prediction. So also consider to have like a pipeline to validate the model before to deploy it in an endpoint. That's it.
Makes sense. Okay, I think this is our last question. So if you have any additional, feel free to drop them in. This is your last chance for now. Of course, you can always continue to utilize the community, but this is the last one we'll take for today. Does MLOps have data validation? For example, ensuring that newly appended records since last execution in a BigQuery table have certain fields populated before you proceed with any further data processing.
I know, Felix, that you work on a component, right, for data validation, I think.
Yeah, that's right. So yes, data validation is one of the important things in MLOps. There are, though, a landscape of tools which you can use. It maybe depends a bit on the skills you also have and the tools you currently use in your team. One go-to open source package I like to refer over and over again is TensorFlow data validation. This is really one way of ensuring that the schema you expect is also present in the new data. So as you said here, for example, one data field is maybe missing. So TFDV would be able to catch that with the schema, but it can actually do also a couple of more things to that, such as data drift and skew detection. You don't need to do skew detection because Vertex AI already has that, but just pointing it out. Though I would say TensorFlow data validation has a learning curve to it. If you want to start a bit simpler and you don't want to detect drift, you don't want to detect skew, and it's really just about making sure that the right data is in the columns, well, then maybe try out Great Expectations. So a variety of tools, and as long as you put them into a Python component or into a container component, there's nothing which stops you from adding another data validation step in your training pipeline, for example.
Great. Awesome. Well, I'm going to surface just the resource to the notebook one more time so you can check that out for yourself. But that's all we had time for today. Thank you so much again, Ivan and Felix, for the presentation and the demo. Thank you everyone for joining us. Any final thoughts or recommendations before we close out today?
Go first. No, go
okay.
first. Go first. Yeah, go.
One thing we didn't cover today is why should MLOps still be relevant when it comes to the new era of Gen AI? There's a very good talk about it from Google Next, where you can look it up also on Google, defining your MLOps strategy for Gen AI use cases, and you realize MLOps is still relevant also for next year. You will need to ensure that the new requirements of Gen AI are met, but anything we covered today is still something which hopefully will be helpful to all of you in the next year.
On my side, I mean, I just want to say that give a try to the Turbo templates because you will have fun, and as always, enjoy coding.
Love it. Ending on great notes there. I'm going to check out that next session myself, and I hope to see you all again at our next session that we have. We'd love to stay in touch with you in the community. In the meantime, thank you so much again, Ivan and Felix, for this session. Thank you, everyone, for joining us, and we hope you have a good rest of your day, evening, or wherever you are in the world.